This is Mr. Agbamu Idanogrene. In today's video, I want to continue from where I stopped in basic rule of differentiation. And today we are going to look at the first function we are going to differentiate using the basic rule. And the function I'm looking at in my today's video is polynomial function. In differentiation, we have different types of functions that you can differentiate. They can ask you to differentiate a function of a function. They can ask you to differentiate a polynomial function like what I want to do today. They can ask you to differentiate logarithmic function. They can ask you to differentiate exponential function. They can ask you to differentiate trigonometric function, implicit function. There are so many like that they can ask you to differentiate. But let's start with the first one, which we are going to use basic rule to differentiate. That is polynomial function. If you recall, in our last video on basic rule of differentiation, I said when you have a function like this, y equals to x raised to power n, we say the basic rule of differentiation in this place says that your answer will now be dy dx will be equals to the power n is going to multiply the coefficient of x, which is n. So the coefficient of x in this y equals to x, and x raised to power n is 1. So y x, so y times 1, n times 1 is n, so nx raised to power n, which is n minus 1. Okay, so this is the basic rule of differentiation. So by the time you understand this, you can use it to solve so many questions. So let's go straight to the point now. So let's start with example. For example, you can give you something like this. Let's take this example. Okay. Example number 1, let's take this. Assuming you are asked to differentiate, I tell you to differentiate y is equals to, let's take this for example, 6x raised to power 6x raised to power 5. Assuming you are asked to differentiate this, so you don't need to waste time on this. All you need to do here is you follow the basic rules. It says when you have a function y equals to x raised to power n, the rule says the power will multiply the coefficient and you subtract 1 from the power. So that is it. So our answer in this case, we don't need to waste time in this. The y dx, let me use mathematics mode. The answer is the y dx will be equals to, you have 5 times 6, which is 30x, then 5 minus 1, which is 4 raised to power 4. So that is the answer. So that is all. So this is one of the basic application of basic rule in differentiation, and function like this is usually termed as polynomial. Okay, let's try another example. Let's see number 2. Let's assume you have something like a constant, something like this. Now let's take y is equals to, let's say 4x. So you know what you are going to get in this case. So the power of this differentiation, the power of this x now is 1. So 1 times 4 is going to give you 4 also. So let's see now. You are going to have dy dx is going to be equals to 4. So that is the answer, because the power is 1. So 1 times 4 is 4. Then 1 minus 1 is 0. So x raised to power 0 is 1. You remember your indices, any numbers power 0 is 1. So take note of that. So all these are basic application of basic rule in differentiation. So take note of this, and remember, it is not always a y and x in differentiation. A question can come like this, so don't always take it as xy. They can ask you something like this. It can be s, it can be something like this. S is equals to, let's say, ut, for example. Let's say s is equals to ut. They can ask you to differentiate something like this. So how do you differentiate something like this? All you need to do is you just write, this time around, no, it will no longer be dy. You want to differentiate s. Let's say you are differentiating s with respect to t. Let's say the question says find ds dt. Let's say this is what the question wants you to find. So how do you find ds dt? So all you need to do here is you follow the basic rule. T is the denominator now, so you are differentiating s with respect to t. So you say ds dt. So you have your ds dt will be equals to, so since u is a constant, it's something like this, just like 4x. Now 4 is a constant, so you differentiate x. Now u is a constant in this expression here, so you differentiate t with respect to s. Now so when you differentiate t, now t have power 1, so 1 times u will give us u. Then t, now 1 minus 1 is 0, so t raised to power 0 is 1. So the answer is ds dt is equals to u. So take note of this. This is when you have a constant and the variable you are differentiating, it's just like ut. So take note of this, very, very important. So if you have something like this, the question can still be in this format. Let's say you have y is equals to, let's say px, y equals to px. So if you want to differentiate this, you now say dy dx, in this case will now be equals to, so p is a constant, just p. X, follow the basic rules, power 1 times p is p, 1 minus 1 is 0, so s raised to power 0 is 1. So this is the answer. So take note of this, very, very important. All these are some basic polynomial functions that you can differentiate using our basic rule of differentiation. Just take note of all this. Okay, let's move on. So if you have something like this, let's take a constant, for example. That is number 4 now. Okay, let's go to number 5. Let's assume you have to differentiate something like this. Let's say y, something like this, y is equals to, let's say, a, where a is a constant. Understand? Where a is a constant. So where a is a constant, so take note of this. So if you are differentiating a constant, what will be your answer in this case? So in this case now, dy dx is going to be equals to 0. You can see it. Why is this 0? You know a is a constant, so whenever you are differentiating a constant, so it's 0. There's no x in this expression, you only have y, there's no x. So for the basic introduction, and when we were doing introduction to differentiation, we said gradient, which is differentiation, dy dx, and gradient, they mean the same thing. And you remember, when you are talking of a constant, the gradient of a constant is 0 because there's no slope. So let me demonstrate it here. This is what I'm talking about. You know, when you have y is equals to, let's say y equals to 4x. Say this y equals to 4x. You can see this is the slope. So if I'm to differentiate this one at y equals to 4x, we said the answer is 4. The y dx will give us 4. So if the y dx is 4, what does that mean? It means that when x is changing, y will change. So the way at which x will change, the way at which y will change with respect to x is by 4. So if x change by 1, let's say this x is 1, y is going to be 4. When x is 2, y is going to be 8. So when x is changing, y is going to change by 4. It's always moving by 4, just like that. That's the meaning of differentiation. So how is y changing with respect to x? When x is 1, y will be 4. When x is 2, y is going to move plus times, that's plus 4 now, which is 8. When x is 3, it's going to move plus 4 again. So y will be increasing in terms of 4. In multiples of 4, ys will keep increasing the way it wants to. So that is that. But if I have a constant, let's take x out of this place. If I have a constant, you can see. So what is the gradient here now? So if you check the gradient of this, let's check the gradient, that is slope. You see it's going to give us 0. You can see gradient is 0. You can see it there. M is 0. But in the other case, let me put x back to this place. So if you have x here, the gradient is going to be 4. You see the gradient is 4, m is equals to 4, which is the differentiation. So this is the basic explanation we did in the first day introduction to differentiation. To take note of that. So that is one of the reasons why we say differentiation of a constant is 0. So if you have questions like this, you have something like, okay, this is number 6. You have a differentiation that says y is equals to, let's say, 7. I say find the y dx in this case. Find the y dx. All you just need to say is the y dx will be equal to 0, because 7 is a constant. Take note of this. It's very, very important. So with this knowledge we have so far, you can differentiate a complete polynomial question without having any stress by following all these examples. If you follow the example starting from number 1, you can see it. Follow your basic rule. 6x raised to the power 5 will give you 30x raised to the power 4. Then 4x will give you 4. Then ut. So it's not always the y ds where you work with. It can be s, it can be u, it can be t. Just know what you are differentiating with respect to the other one. If you are differentiating s with respect to t, so ds dt will now be u, because u is the constant. So take note of that. Then this is another example. You are differentiating y with respect to s, but p is a constant. Then if you are differentiating the constant, you are going to get 0. So take note of that. So if you have a situation like this, that will now take us to number 6 now, which is differentiation of a sum. This is have number 6. Okay, that's number 7. Okay, so if you are asked to differentiate something like this, you can ask you to differentiate y equals to, this time around it will not be a single term like this, the expression can be long. Let's say you have 5x raised to the power 2 minus 7x plus 9. Let's say you are asked to differentiate this function. So this is a polynomial function. How do you differentiate this kind of function? So straight to the point, the y, okay, let's use math mode. The y dx is going to be equals to, so this time I follow the basic rule of differentiation. Differentiate each term based on what the rule says. Y equals to 5x squared. So differentiate this one first. The rule says power n with times the coefficient, which is 2 times 5. You are going to get 10. Then subtract 1 from the power. 2 minus 1 is 1. So this is 10x. You are through with that. You go to the next one. 7x. You put your minus down. 7x, remember the rule in number 2 example here, a constant and x, something like this. 4x give us 4 because 1 minus 1 in the power is 0. So x raised to the power 0 is 1. So this is going to give us 7. Then the last one, which is a constant, we say differentiation of a constant, which is the example we did here. When you have this differentiation of a constant, y equals to a, when a is a constant, so the y ds is equals to 0, so which is something like this. Y is equals to 7, so the y ds give us 0. So by the time you take note of this, you see that differentiation is not difficult, just for you to know your basic mathematics rule that you are going to apply. So that is the answer of this number 7. Very simple and straightforward. So if we go to number 8, let's see another example. You can be asked something like this. Let's take this for example. You can be asked to differentiate. Let's say you are asked to differentiate 6x raised to the power 3. Okay, let's get it in math mode. 6x raised to the power 3 minus 5x squared plus 1. This time around, everything is dividing 3x raised to the power 2. Let's say you are asked to differentiate something like this. How do you do this? So differentiate this with respect to x. Remember what I said? You go straight to the point, differentiate each term. But this time around, there's a denominator here, so you cannot differentiate each term like that in this case. So this is differentiation of a quotient, and it's also one of a rule in differentiation, quotient rule. But since we have not done that, you can do this without using quotient rule. How do you do that? What you just need to do, use your knowledge of indices now. If I use my knowledge of indices now, let's take y to be equals to this expression. Let's take y equals to, so with knowledge of indices, each term 6x cubed divided by 3x squared. I have 6x cubed divided by 3x squared. So you do that, then you move on, minus 5x squared divided by 3x squared. You get what I'm doing? This is just basic mathematics. Divide each of these numerator, each term in the numerator, by the denominator. Then you move on, plus 1 divided by 3x raised to the power 2. So this is what you need to do first. Okay, we have not started the differentiation. We just need to put it in a comfortable way for us. So put it in a way that will be okay for you to solve. So with this now, we now have y. So we now have y is going to be equals to, now let's divide what can go. So 6 divided by 3, you have your 2x. So x squared cancel this, you have 2x. That is this point, minus the x squared will cancel x squared, leaving 5 over 3 here. You can see it, 5 over 3, which is minus 5 over 3. So there's no x in this place, then plus 1 over 3. Then this is x raised to the power 2. Also from your knowledge of indices, you can turn it to something like this. Let me arrange it. Let me do it in this place so that you get what I'm saying. If you recall, in indices, when we have 1 divided by a number, let's say 1 over 2 for example, you know 1 over 2 is the same thing as 2 raised to the power minus 1. Think you remember this. Fractional index, negative index in the law of indices, 2 raised to the power minus 1 is the same thing as 1 over 2. So it's a very important law in indices, so you can solve this one. So 1 over 2 will give you 0.5. If you also solve 2 raised to the power minus 1, you will see that you are still going to get the same result when you tap your equals to. You can see both of them give us the same result. So take note of that, they are the same. So with this knowledge, 3 is already in the denominator here. So 3 is already in the denominator, so you just put your 1 over 3. Then this also, you also have 1 over x squared. So this 1 over x squared is going to be x raised to power minus 2. So that is that. So take note of that. So it will be easier for us to differentiate this now. X raised to power minus 2, you can differentiate it easily now. So what are we going to do to get our final answer? You just say dy. Just say your dy dx will now be equals to. So you differentiate each term now. Now it's easier for us to differentiate them following our basic rule now. Follow the basic rule, you are going to have 2s is going to give you 2. So 5 over 3 is a constant. So there's no x attached to this. So it's a constant, so this will be 0. Then the next one is this minus 2 now. X raised to power minus 2. So if I differentiate this, the coefficient of x raised to power minus 2 here is 1 over 3. So minus 2 will times the coefficient. So we are going to have minus 2 over 3. So that is the answer for this side. Then x, we now say subtract 1 from the numerator based on the basic rule now. So minus 2 minus 1 is going to give us raised to power minus 3. So that is the answer to this. So that is the answer. Then you may want to rearrange it in the proper order now, the way the question came in this form. So you are going to have dy and dy dx will now be equals to 2 minus 2 over 3. 2 minus 2 over 3. Okay, 2 over 3x raised to power x raised to power 3. So this is the answer for this question. When you differentiate this, this is the answer you are going to get. So that is all I want us to get in differentiation of polynomial function. So anyhow the question comes, if it comes in a fractional form like this, just know how you can differentiate it, follow the basic rules, and you do it. If it comes in, let's say the question comes in this form, for example, you have let's say square root of x. They can ask you to differentiate square root of x. So what do you do here? You already know that if this question, for example, now let's take square root of x, let's take y. Okay, this is y is equals to square root of x, and you are asked to differentiate this. You should know that in your law of indices, y is the same, x square root of x is the same thing as x raised to power 1 over 2. So you should know this law. So in calculus, in differentiation, we don't joke with things like this. So y equals to square root s, the same thing as y equals to s raised to power r. Then if you want to differentiate this now, you have your dy dx. Dy dx will now be equals to, then the power of x. The power of x, you can see the power of x is 1 over 2. You have 1 over 2. It will multiply the coefficient of x. Then x will now be raised to power half, that's 1 over 2 minus 1. So this is going to give you minus 1 over 2. So let's adjust it well. It's going to give you minus 1 over 2. So this is the answer of this differentiation. This is the answer of this differentiation. Let me put it in the right way. So it's like this. So 1 over 2 is the power of x. So it will multiply the coefficient of x, which is 1 over 2x. Then the power of x, you subtract 1 from it. So half minus 1 is minus half. So that is it. Then if you want to put the answer in a root, this square root form, you are going to have dy dx is going to be equals to 1 over 2 is already there, 1 over 2. Then in the denominator, now you know this is negative power, just like this, minus 2 will now turn to 1 over x to the power 2. So the same way, minus half will now be 1 over x raised to the power 2, which is x raised to power 1 over 2. So it will now look like this. So that is it. So take note of what I'm doing. They are very, very important. Then your final answer is now going to be in this order now. Let me adjust it where now like this. Now is the y dx will now be equals to 1 divided by 2, which is square root. Take this out of this place. That is 1 over 2 square root x. So this is your final answer. And you know why this is the answer? Because x raised to power half, see, it's the same thing as square root x. All these are basic laws of indices. So this is the answer of differentiation of square root of x. So when you differentiate square root x, the answer is going to be 1 over 2 square root x. So take note of this. So there are so many they can ask you to differentiate, so many questions they can ask you to differentiate. Just know the basic rule and you know what to do. They can even ask you to differentiate. Let's say you have something like this. They ask you to differentiate y is equal to, let's say, 1 divided by x. It looks simple, but if you don't know your basic rule of indices, you may not be able to differentiate this very well. You'll just be wasting your time. But we have other rules like quotient rule, differentiate this for you easily. So all you just need to do first is to put it in this simple order now, or this kind of order, so that you can easily solve it. So which is x raised to power, so x raised to power minus 1. So you remember your law of indices. So after you have done this, so your final answer, the y dx now is now going to be equals to, then you remember the basic rule now. The basic rule of differentiation says the power will multiply the coefficient. Since the power is minus 1, you are going to have minus x, then subtract 1 from the power. The power is minus 1 minus 1. You're going to be raised to power minus 2. So minus 1 is minus 2. So your final answer, if you arrange it in the right order, the y dx is going to be equal to minus 1 divided by x raised to power 2. X raised to power 2. So this is your final answer for this question. So take note of all this type of question. And you know why this is the same thing as this? They are the same because this minus 1, the coefficient of this x raised to power minus 2 here, the coefficient is minus 1. So when you rearrange it now, this x raised to power minus 2 is going to turn to 1 over x raised to power 2. So if x is going to be 1 over x raised to power 2, then minus 1 is going to go on top. It's just like a situation like this. If you have 2x raised to power, let's say minus 3. So this one is going to be equals to, this 2 is going to be in the numerator, to now be 2 divided by x raised to power 3. So that is the result. So these two, they are the same, they mean the same thing, because x raised to power minus 3 is the same thing as 1 over x raised to power 3. You get it now? Because x raised to power minus 3 is the same thing as 1 over x raised to power 3. So you don't forget all these basic rules. These two, they mean the same thing. So if x raised to power minus 3 is 1 all over x raised to power 3, and 2 is already multiplying this value. So if 2 is multiplying this value, that means 2 is going to be here, 2 times, something like this. 2 is already multiplying x raised to power minus 3, and x raised to power minus 3 is 1 all over x raised to power 3. When you follow your basic rule, then 2 times 1 over x raised to power minus 3, that means 2 times 1 is 2. So that's how you got this. So that is the same result here. So minus 1 is multiplying x raised to power minus 2. So you now have minus 1 divided by x raised to power 2. So you have so many problems like this in differentiation. So that's why I took my time to review all these ones with you. So this is how you differentiate basic polynomial functions. Take note of everything we did today, starting from the basic rule of differentiation, how we applied it in solving all these simple examples we have here, coming to this type of example, and just like that. So with this good knowledge of this aspect of differentiation, we can confidently move to other aspects of differentiation, like function of a function, product rule, and the rest. But for now, let's stop here. And before we go, I just have few questions here I want you to practice, which is an assignment. I'll practice these few questions just to be used to the solution of differentiation. You can see number 3, you have square root here. Put it in the right order, use your law of indices, arrange it in polynomial form. So when you have it in that form, you can use the basic rules, the power times the coefficient, and just like that, and that is all. So that is all for today. Do have a nice time. Take care.